Hey everyone, welcome to the second part of DNA replication. In this part, we are going to talk about the formation of the leading strand. So because DNA is antiparallel, what's going to happen is one strand will be read from 3 to 5. In other words, from the origin of replication towards our replication fork, we're going to encounter the third carbon or the third OH group, then the fifth OH group, and that's going to be that parent strand. When we make the new strand of DNA, and this is going to be my new strand right here, this line, I'll go ahead and just kind of highlight it in blue. This strand right here, when it is made, it will be made 5 to 3 counter to that parent strand. So this right here is your new DNA, and it's going to be made from 5 to 3 directions. So from the origin of replication, the first carbon you would encounter is a 5, the last carbon you would encounter is a 3. So going this way, it is 5 to 3. DNA polymerase III, which is the main enzyme that's going to build the new DNA molecule, because of its requirements, is going to need, or is going to be able to add only to that 3' carbon. And since there's no 3' carbon here, we're going to have to lay down a temporary primer made of RNA. Now that primer is made by an enzyme called primase, which is pretty easy to remember because remember ACE indicates that it's an enzyme. And then once DNA polymerase III begins attaching to that third carbon and it starts adding and pairing off, let's say for example this is A, then it would put a T. If it was a C on the parent strand, then we would put a G. Because this gets started, we can eventually replace this RNA primer. We don't want RNA anymore. This is a copy of DNA, so we're going to have to replace this. And then that primer is replaced with actual DNA by a different enzyme called DNA polymerase I. And so it's going to replace the primer, and then there's another enzyme that will glue these segments together. This is called ligase. Okay, so ligase is the enzyme that's going to glue these pieces together, and the primer was there to provide that free 3' carbon. That's the one that you want at the end to start the chain. And because that's a 3' carbon, that makes this the leading strand. DNA polymerase III is just going to start adding those nucleotides one right after another, working away from the origin of replication towards the replication fork. Helicase is going to keep opening up and making more DNA available, and eventually what you're going to see is a copy of the DNA attached to the parent strand. So now this is one new complete strand, half old, half new, which is what we learned from our mesosyn install experiment. So this strand over here is called the leading strand, and the way that you can identify the leading strand one more time is because when on your new strand of DNA, not the parent, on the new strand of DNA, what you're looking for is the last OH group, is that last carbon going to be that 3' carbon. If it is a 3' carbon, DNA polymerase III can just start adding nucleotides continuously, forming what is known as the leading strand. But again, I'm going to stress this one more time. You can tell it's the leading strand because on the new DNA, not the parent, on the new DNA, your last carbon you're going to encounter is the 3' carbon. That's how you know it's the leading strand. So this is the parent of the leading strand. This is the newly formed DNA that is your leading strand. And your leading strand is going to be 5 to 3 on the new DNA. The parent strand would have been read 3 to 5, moving from your origin of replication towards your replication fork.